fourth grade into math lesson 18.2. Identify and draw lines of symmetry. I can identify two-dimensional figures that have line symmetry. I can draw all lines of symmetry on a two-dimensional figure. So once again, two-dimensional figure is what? Is a flat shape. Okay. And then of course line of symmetry is where you can fold a shape in half and it should line up and be able to come up against each other and fill in the same space. Step it up. Number 1. A computer club is designing new signs to have printed and displayed outside. The two-dimensional figures used for the signs need to be symmetrical. Trace, cut out, and fold the figures below in different ways to test for line of symmetry. Identify the figures that appear to have a line of symmetry. Okay, so we could do that, or you guys could also use your mirrors. Okay, so go ahead and with letter B, go ahead and figure out where you think lines of symmetry would be on these shapes. Do all of those have lines of symmetry? No. Okay, all right, go ahead. Okay, so like we discussed earlier, first of all, we look at like the horizontal vertical way, right? And then we look at the diagonal. So what about the arrow? Can it be horizontally? Vertically? No, and then not diagonally either. What about the rhombus? Yes. So horizontally, right? What about vertically? Yep. What about diagonally? Yes. Right here. So how many lines of symmetry does that have? 4, right? Okay. What about the pentagon? Yep. Which way? Vertically, right? Okay. What about the bubble? The word bubble? Nope. Okay. What about the quadrilateral? Nope. Okay. And then what about the triangle? Yes. So vertically? Yep. Horizontally? No. What about diagonally? Yep. And what about diagonally again? Yes. Okay. Now, what type of triangle does that have to be for that to work? It has to be an equilateral triangle, right? Or to have 3 points of symmetry. What if it was an isosceles triangle? A scalene you could not, but could you with an isosceles? Yes, you could put it from the tip down to the side across, right? Okay, but you have to have the same sides of equal length be on the line of symmetry, or on opposite lines of symmetry, right? In order for that to work. All right, so step it out. Number 2, the polygons below are choices for the new sites. Which of the polygons are regular polygons? So what do regular polygons have to have? 3 equal sides. Not necessarily 3 equal sides, but all the sides have to be equal, okay? Because if it was a pentagon and it's a regular polygon, would it have just 3 equal sides? No. If it was an octagon and it had all equal sides, that would be a regular polygon, but would it have 3? No, it'd have an octagon. 8, right? Okay. All right, so which of the polygons are regular polygons? So of those, which ones are a regular polygon in the picture? The square, what else? So of these pictures, guys, okay, so regular polygon has all sides of equal length. So the square, what else? Trapezoid. Does the trapezoid, are all those the same? No. Remember, they have to have tack marks on all the sides. What about the regular octagon? Yes. Okay, and then what else? The equilateral triangle. Okay, so identify the number of sides for the polygon. So, and then draw the lines of symmetry. Number of sides for the isosceles triangle? 3, right? And then vertically, we can have a line of symmetry. Can we have it anywhere else? No. This is kind of what we talked about on the front, right? Equilateral, you have 3 different lines of symmetry, but in isosceles, you only have 1. Okay. The square, how many sides? 4. Can I horizontally? Yes. Yep. Vertically? Yes. Yep. Diagonally? Yes. Yep. And then diagonal the other way. So how many lines of symmetry? 4. Trapezoid, number of sides? 4. Horizontal line of symmetry? Yes, no? Yes. No. Vertically? Yes. Yes. And then 1 line of symmetry. Remember, use your ruler. Okay, the regular octagon, how many sides does it have? 8. Okay. Now, why did you use those little tap marks that indicate that all those sides are equal? What could you use those for to help you with your lines of symmetry? Could you use your ruler to line it up and draw your lines of symmetry? Yep. So, can I draw it horizontally? Yes. What about vertically? Yes. What about diagonally? Yes. What about diagonally? Yes. Is that my only lines of symmetry? No. Can I also go through the vertexes? Yes. Yep. So I can go point to point across from each other, right? Okay. So now, how many lines of symmetry did that have? 8. Okay, so what are we noticing? That regular polygons, ones that have all the same equal amount of sides, you get what with the lines of symmetry? The same amount, right? Okay, so equilateral triangle, how many sides? 3. Okay, lines of symmetry. So I'm going to go from the point down to the middle of the side across from it. Point to the middle of the side across from it. Point down the middle of the side across from it. So how many lines of symmetry? 3. Number 3, Nathan's art studio is painting clay tiles to use in a walkway. Nathan starts in a design that will have 2 lines of symmetry. Okay, so we need to get it vertically first. Okay, so if I start here at the line, and I'm going to come down 1, 2, 3, put a dot here, and then connect it from here to here. Over here, they go over 2. So then I'm going to draw my line out. Okay, then over here, they come out 1, 2, 3. So 1, 2, 3. Draw my line to there, and then I'm going to connect my top to my bottom dots. Okay, then they also have a line coming from there to the middle of those 2 dots. So do I have my vertical symmetry done? Yes. Okay, now we're going to work on my horizontal. So I bring my line down on both sides, 1 space. Then I come over 3 spaces and draw a line. Come over 3 spaces and draw a line. Then from there, I go down. If I come to this middle right here, I go down 1, 2. So 1, 2, I'm going to put a dot right here. So it's technically 3 rows down from that other dot. And then I'm going to connect those in the form of a V. Okay. Then from that V, I go down 1 more space. So I'm going to go right here, and then I connect my outer, hold on. Not my outer there. Hold on 1 second, guys. Okay, that's the center. but then I need to go 2 out from that. So I'm going to come here and here, and then connect my dot. Okay, so would this be as easy to do without the dotted lined paper? No. If we did not have those equally spaced, would we get lines of symmetry? No. Check understanding number 1. Rocco draws a regular polygon with 12 sides. Next, he draws all the lines of symmetry. How many lines of symmetry does he have? How do you know? So what did we learn on the lines of symmetry part? What did we learn before? For regular polygons. If they all have equal sides of length, then you're going to have the same number of lines of symmetry. So how many lines of symmetry would a regular 12-sided polygon have? 12. So 12 lines of symmetry. And then we just discussed that as to why, right? Because if all of the sides are equal, you'll have the same amount of lines of symmetry. Okay? Draw all the lines of symmetry for this figure. Can we do it horizontally? Yes. So take your ruler and draw that. Can you draw it vertically? Yes. Diagonally?
No.
You tell me. No. Okay, actually, guys, can it be vertically? No, because what do you notice? The right side, these points over here, these points right here, they kind of stick out more than these do. So if I would try and fold that vertically, would it work? No, it would not line up. If I cut that out and try to do it, it would not work. Okay, what about number 3? Horizontally?
Yes.
Yeah, take your ruler and draw it. Vertically? Yes. Diagonally?
Yes.
Yes. Both ways, correct? Okay, so how many lines of symmetry did that have? 4.